maximum number of points from grid queries. Yeah, so we are giving a grid, and we have the queries, and all those queries is for the grid. So for example, for the first one, for this number 5, so for this query 5, we're gonna start in from the index 0, 0. It's gonna be the top left corner of the grid. We're gonna start in at this position, and we're gonna check all the numbers. So if it is less than this 5, so we're gonna spread it in 4 directions. So we're gonna put 2 inside, and we can also have put this 3 inside and 3 inside, but we cannot put 5, 7, and 5 because that is more than equal to 5. So how many numbers? There are 5 numbers. And what about the second one? For this is 6, and for 6 we can find there are 8 numbers. And what about 2? We're gonna start from here. So all the numbers is smaller than 2. It's gonna be 1. So we're gonna return a 1. So this is gonna be the final result. Yeah. Maybe you're gonna think about why not we just sort the queries. So let me use another color. So if we can sort the queries like 2, 5, 6, will this help us to solve the problem? Yeah, if we have a 2, 5, 6, maybe we're gonna use BFS or DFS to search to check how many numbers, but there's a duplicate search. So for example, you're gonna search 2, you're gonna start from here, and you're gonna search it. Yeah. So what about the next number 5? You're gonna still start from this position, and you're gonna search it by using BFS or DFS. And while you are use this query 6, you're still gonna start from this position. And it means even you sorted the array, it didn't help you solve the problem. Yeah, maybe the BFS and the DFS cannot solve the problem. We're gonna think about some clever ways to solve the problem. Yeah, because definitely we cannot solve it by the brute force, because the length of the queries is 10 to the power of 4, and the length of the array, I mean m times n, it's gonna be 10 to the power of 5. So 10 to the power of 9 definitely is not possible. Yeah, so this means if you use brute force, definitely it's not possible. I mean the brute force is for each of the query you're gonna use BFS or DFS to search that. And a clever way to solve the problem is that since we can sort the queries, so what about we just sort the arrays? But this is just a grid. It's a 2D matrix. How can we sort a 2D matrix? What if we sort the 2D matrix? What's gonna happen? Yeah, because if we sort the 2D matrix, the position is going to be changed. And how can we manipulate all those positions? So for example, after sorting, it's going to be like 1, 2, 2. I just list a few, maybe 3 and 3, and 5. And for all those numbers, how can we manipulate the positions? Even if we can manipulate the positions, how can we use BFS or DFS to check in 4 directions? We cannot do that. Yeah. So this means we cannot use the basic data structure to solve the problem. We have to use some high level or advanced data structure. Yeah. So the unified comes into mind, because the unified can directly solve this kind of problem. So we are not caring about where is my positions. I just need to check the numbers separately. If this number is okay, I find it. If this is my number, if this is less than or equal to query, I'm gonna connect it first. I don't care if this is at the top left corner or not. I don't care about it. I just connect it. I'm gonna connect all those components first. For example, this is my first component. This is another component, and there is another component. It is connected like that. Now, after connecting all those components, I have the component, and I just wanted to check which component has index 0. I'm gonna check this position, the top left corner, this position as my index 0. So for example, this one has an index 0. So for the index 0, I'm gonna check how many connected components, 1, 2, 3, 4, 5. So I'm gonna return a 5 for this query. And after some time, maybe this component connected more, it's gonna be 6. So for next query, the result gonna be 6. Maybe after some time, it's gonna connect it to 7. So for the next query, it's gonna be 7. Yeah. So this is gonna be a clever way to solve the problem. We're gonna use the unified to solve the problem. But after using the unified, because we already sorted the arrays and sorted the queries, so the time complexity would be n log n, maybe k log k. K is the length of the queries, and plus mn log mn. Yeah, because mn gonna be the 1D array. For using the unified, we're gonna turn the 2D array into a 1D array, and after that we're gonna sort the 1D array. Yeah, so if we sort the 1D array, and then we're gonna compare this 1D array with the queries, because we're gonna sort the queries in increasing order, and this 1D array we're gonna also sort it according to the each of the values inside the grid in increasing order. Yeah, so if it is in this way, definitely from the beginning the unified is going to be some component, and then it's going to have more and more component. We can just get the final result in this way. Yeah. So for the unified, normally I will prepare some template for the unified. Basically, I will not try to write it the template from here, because it takes some time. Although I can write it, but I prefer to use a template. Let me just find some template for this problem. Yeah, normally you can also prepare your own template. Yeah, because basically there are a lot of templates to use for the unified. So I just used this very basic template. So this basic template is for solving the continuous array problem. Yeah, I'm gonna put it outside the class. I'm gonna put it out of my class. So while I'm preparing a template, I always prepare a class, because inside of the class I'm gonna prepare all kind of a method I needed for my template. Basically, for the unified, I need a find, is connected, and union. So that is my basic method. And I also prepared a rank, and this rank is for the size. Yeah, because after all the components connected, I need to check the size. So for example, this is the index 0, the first number. I need to check the size. So the size is going to be 3, and this rank is for checking the size. Yeah, because definitely this rank is for checking the root component. So if this is the root component, I know this number is going to be 3 inside my rank array. It's going to be the maximum. Yeah. Now, if we understand about the template, we can start to solve the problem. So I'm going to use n should be equal to, let me use prepare some variables. So r and c and directions. So r going to be the length of the grid, and c going to be length of the grid 0, and then I'm going to prepare for directions, and going to be 0, 1, 0, minus 1, 1, 0, and minus 1, 0. So I'm going to prepare for directions and the row and column. Yeah. Now I'm going to prepare the total number of the element for the grid. So this n going to be r times c. Yeah. Now I'm going to use the unified. So the UF going to be the capital UF. I'm going to put n inside. So this means I'm going to use a 1D array to initialize the unified. Yeah. So definitely from the beginning, I've already turned a 2D grid to a 1D array, but I didn't put anything inside my unified yet. I will put it later. Now, our template has already finished, and just prepared some basic variables as well. As you can see, the r and c directions and this variable n. Now we're gonna focus on the problem. Yeah. So for the final result, we're gonna have a result array. Let me just prepare a result array. It's gonna be 0 times the length of the queries. This is gonna be my final result. And I also need to prepare. Let me think. I also need to. Yeah, it just goes out of my mind. I also need to prepare something else. Let me think about it. Yeah, because this is the query. I'm going to prepare a index array. So this is going to be just a mapping from the my mapping of the index. So for example, after the queries has been sorted in increasing order, the index is going to be in different places, but I just need to remember where's my initial position. So this is why I'm going to prepare an index array. It's going to be a list of range of length of the queries. Now I need to prepare a mapping of my position of the index. So this means for this number 5, I need to remember the position. It is not 0 because after sorting this 5, the position is going to be 1. So I need to remember where it is. So I'm going to index.sort k equal to lambda, and with this index, it's going to be the queries index. So the query x. So this is going to be a mapping for the index. And I also need to prepare a variable I. Yeah, but before that, let me just prepare a 1D array, because for this grid, for all those numbers, I should be sorted into a 1D array. So let me just prepare that. It's going to be a sorted array. So inside, it's going to be the grid RC. So inside of the tuple, grid RC with R and C. So for R in range capital R, and for C in range capital C. Yeah, so this is going to be the 1D array for the nums. Now I turned it into a 1D array, and this nums has already been unsorted. Now I'm going to prepare an index I. So this is going to be the index from the first number of the 1D array. So this index I is just for this nums. It is the first index because I'm going to compare with my queries later. Now I can enumerate the queries. So for J, Q, in enumerate with the queries. The queries should be a sorted query, so I'm going to sort it. Yeah, I copied it too much. In increasing order, so I'm going to sort the queries as well. Yeah. Now I'm going to have a tag. So currently I get the index, it is this J. This is my first index, but I'm going to need to compare with this I. So I'm going to use a while loop. So while my index I is less than the length of the nums, it's going to be n. Because this n is prepared for this nums, I'm going to use this variable n. While I less than n, and I need to while this I is less than n, and I need to check the numbers. So it's going to be the nums I, and while this number is less than my query. Yeah. So if it is less than the query, it means this number is a possible result, is a valid result. Yeah. So I'm gonna use this result. So it's gonna be I'm gonna use a value. It's gonna be a value with R and C, and it's gonna be it's gonna be the nums I. Yeah. And here, because I'm checking, I'm gonna check the value. I'm gonna check the values. It's gonna be the nums I. This is my nums position because nums gonna be a tuple with 3 values. Where's my nums? It's gonna be here. Yeah, with 3 values, but I need to take the value. It means it nums I 0. This is my value. If it is less than Q, it means I'm gonna connect it with the 4 directions. So I'm gonna connect it. So first of all, I'm gonna take it out. So this is my position, RC and value. Now I'm gonna check the 4 directions. So for dr, dc in directions, I'm gonna prepare this row and column as the new position. It's gonna be r plus dr and c plus dc. So this is gonna be the new position. Now I need to check if it is inside the boundary or not. So if the row is inside the boundary, and the column is also inside the boundary, and this is the column, and I also need to check so if this row and column just inside the boundary, I also need to check the grid row and column. Because inside the 4 directions, I also need to check the new direction, new position. If this is also less than Q, and those 2 numbers are not connected. But I will write it later. I will just use the uf.union. I'm going to union it. So I'm gonna union basically two index. So the first index is gonna be r times c plus c, and the first one is gonna be row times c plus column. Yeah, so here is just a basic mathematical calculations. If you are familiar with the 2D grid of unified, basically you know what is the meaning. So for example, if this r equal to 0, 0 times c is going to be 0, and this is going to be the column position, because we're going to turn the 2D array into a 1D array. But we need to find the position for this 2D array. Yeah. We need to find the position for the 1D array. So this is just a 2D representation, and now we're going to turn it into a 1D array. We find the position and we're going to union it together. Yeah. But for this union, we have to check if they are not connected, we can union it, because later on we're going to use the rec to calculate it. Yeah. It has to be not connected. Otherwise, if it has already been connected and then we connect it again and our rank didn't work because the rec plus the two mass values, we don't need to do that. Yeah. So if it's not connected and another check, we need to add another check, and uf dot is connected with the values, but we need to check if they are not connected, and then we're gonna connect it and we're gonna union it. Yeah. If everything's okay, it means we finished the 4 directions, and our index I gonna plus equal to 1, because we're gonna continue to check the next position. So if we finished all the while loop, it means we've already finished the first query, and what to get the result for the first query. We need to check. We need to check the. Let me think. We need to check the values. We need to check this position basically. We need to check about this top left corner, this position, and we need to check this. We need to check this number first. We need to check if this number is less than the q. If it is less than q, and then we're gonna return something. We're gonna count how many numbers inside my component. I mean, what is the size of my connected component? I need to check. So if this number is more than the query, basically I don't need to check. Yeah. So where is my number? So it's gonna be. We can use. So my number, I have to remember the position of my number. My number gonna be definitely for each of the number. It is fixed at the top left corner, because in nums array it has already been sorted. I don't know where it is. Yeah, but definitely for this grid 0, 0, and this is gonna be my number. Yeah. So if this is less than q, now I can have the result. So the result gonna be the result of I'm gonna use the hash table, hash array index, and with this c, and I need to get the size. It's gonna be uf dot rank, and for this rank I'm gonna use uf dot find, because I need to find its parent. So it's gonna be 0. Because 0 is this number. 0 is the position of this number. Yeah, because this is the index. Because I've already turned it to be like 0, 1, 2, 3. So that's gonna be my index or my rank. And then for the index 0, maybe I have a count of 3. So that's gonna be my size. Now I can return the final result if everything is okay. Yeah, but I'm not sure because I'm writing basically a lot of code. Yeah. Now we are going to check if everything is okay. But basically here is template. I'm pretty sure that should be okay. But for here, I need to have a check if everything is okay. Let me just run it. This object is not callable. Index z. should be uf.find. Yeah, I need to let me check. Yeah, I need to find this 0 uf.rank with uf.find 0. So this is gonna be my first index. Yeah, let me just think about it. Because my union find, for my union find array, I've already sorted. Yeah, let me just print out what is the uf.find 0. Can I find it? So it is 0. And let me just check this index j. Maybe. This is 2 and 0. So the result to uf.rank. Yeah, I did something wrong because this is a list. I just make it as a method, as a function. I cannot do that because uf.rank is a list, because list is not callable. Yeah. Now let me just run it to check. Yeah, it seems it works. Yeah. Now let me just delete the print line and submit it to check if it can pass. Yeah, as you can see, it works. And the speed, I think it is okay. It is less than 1 second, and basically it is okay. Now let's analyze the time complexity a little bit. Yeah. So for the union find, we don't need to analyze because it's just a template. We can analyze it directly. And now we're gonna analyze from here. So the index.sort, it is the length of the queries. It is n log n. Yeah. And another one is the nums.sort. So this is mn times log mn. Yeah. So the mn is 10 to the power of 5, and the query is 10 to the power of 4. So we can ignore that because this is smaller. So the final time complexity gonna be 10 to the power of 5 times log 10 to the power of 5. That is why we can pass. So thank you for watching, and see you next time.